Hey guys, welcome to the video tutorial for Kirchhoff's rules. And this is a really useful tool for when you start getting into really complex circuits with a lot of different branches and you're wanting to figure out the current across a certain resistor or the voltage drop or something along those lines. And so it's just two rules. The first rule says at any junction, the sum of the currents in must equal the sum of the currents out, which we've already kind of touched on with the other examples. With the example where we had 17 milliamps going in, we had to have 17 milliamps coming out, and so those two resistors drew 10 and 7 milliamps respectively. So we've already kind of used these rules, but in a more simple fashion, whereas problems in your homework get more complex as you go. And so this is just a simple example here of what we're going to talk about. Now, the other rule says the sum of changes in potential about a closed loop or path equals 0. Okay, so let's look at this simple circuit here. We've got 12 volts, and I've got various points along this circuit. So I've got E here, A, B, C, and D. And so if we look at the voltage potential change from E to A, well, nothing happens. So in other words, the voltage change from V to A is 0. Well, now let's look at VBA. In other words, the change from B and A. So if we look at that, we see that the total resistance, in other words, we need to figure out the equivalent resistance, going through this whole circuit, and from that figure out what my current is. And so I need to figure out what our equivalent is. Well, it's nice because these two resistors are in series, and so my equivalent resistance is 690. And so if I want to know the current being drawn through each of those resistors, I just utilize V equals IR. So 12 equals I times 690. So 12 divided by 690 gives me a current of 0.0174. So I equals 0.0174 amps. So I want to stress, when resistors are in series and you figure out the current, that means that each of those resistors are experiencing that current. In other words, this resistor is drawing 0.0174 amps, and this resistor is also drawing 0.0174 amps. So what I can do is figure out, okay, what's the voltage drop from B to A? And so if I do that, I get let's go VBA equals my I times my resistance, which is 400. Now if you notice, I'm going B to A. So VBA is in a sense going backwards. Well, 0.0174 times 400 gives me 7, but VBA, we need to view that as negative 7. Okay? VAB would be 7 volts. VBA is negative 7 volts. Now, we need to look at VCB. You do the same thing. I times 290, and here I get negative 5. Now, if I go C to D, or D to C, either way, that is also going to be 0. So we'll go DC is equal to 0. So far I've got 0, minus 7, minus 5. So far I've got negative 12. Well, if you look at V and then E to D, that gives me plus 12. So basically, the point I want to stress is A to B, B to C need to add up to my total voltage, which is 12. Or A to B, B to C, that gives me negative 5, negative 7. E to D gives me positive 12. So in other words, the voltage drops need to add up to my total voltage. So if you looked at it like this, and if you calculated VAB, well, that gives me 7. And then VBC, that gives me 5. So then if you look at VDE, you're going negative to positive. And so VDE is going to give you negative 12. So do you see how it cancels out? You can view it either way. You can go clockwise or counterclockwise, it doesn't matter. The point I want to stress is A to B and B to C need to add up to my total voltage that I start with, which is 12. In other words, think of it like a conservation of charge. Okay? So that is Kirchhoff's rule in a nutshell. Now here we don't have a whole lot of branches to deal with, so we don't really have to worry about the currents. But in the next video tutorial, we're going to look at some homework type problems. There's also a really great example to look at, and it is on page 530. It's a great example. It's pretty complex, but you have a lot of different branches, and so you have to deal with a lot of different currents. But it's still a really good example to look at. But in the next video tutorial, I'm going to look at some homework problems with you.